Iranian ammunition depot outside Isfahan disappeared in a chain of secondary explosions. One blast triggered the next, and the munitions burned for hours. That is the signature of a strike that hit something Iran had buried deep underground. What makes it remarkable is that the aircraft responsible never entered Iranian airspace. It released its weapons, turned away, and had long been heading home by the time the fires began. 5 weeks into Operation Epic Fury, a campaign that struck more than 13,000 targets, destroyed over 80% of Iran's air defense network, and reduced its ballistic missile launch rate by 90%. Every major headline has focused on stealth. People talk about the F-35 clearing the way. They talk about the B-2 hitting places no other aircraft can reach. But a third bomber has been flying every night since day one. Not from a carrier and not from a classified base, but from a Royal Air Force station in the English countryside. It is 70 years old. The airframes striking Iran today were assembled before some of their pilots' grandparents were even born. Here is the part almost no one in the mainstream press is clearly explaining. At the start of this war, that aircraft could not go anywhere near Iran. Its radar cross-section is almost as large as a small warship, the biggest of any bomber in the American fleet. Iran's air defense network was built specifically to detect and destroy aircraft exactly like it. So how is the B-52 Stratofortress dropping 2,000-pound bunker busters on underground targets in Iran's industrial heartland by week 5 and still making it home safely? The answer is not the aircraft itself. The answer lies in the physics of how the battlefield environment changed around it. And that is what needs to be broken down. Iran did not just build air defenses. It built an entire system designed specifically to make a 70-year-old bomber obsolete. And for the first 2 weeks, that system worked. Since the rise of standoff cruise missiles in the 1980s, the B-52 has survived by staying outside the kill zone. From Desert Storm to Operation Iraqi Freedom, the formula remained the same. The B-52 launched its weapons from a distance enemy air defenses could not reach, not because it was stealthy, but because no one had a missile with enough range to close that gap. In 2016, Iran bought the S-300 PMU-2 from Russia precisely to close that gap. The system has an engagement range of roughly 120 miles, with detection radar reaching about 185 miles. For the first time since the B-52 adopted its standoff doctrine, an adversary had missiles capable of threatening it even at launch range. Iran also built the BAVAR-373 domestically, layered it with TOR-M1 short-range interceptors, and distributed radar nodes across the country so that no single American strike could blind the entire network at once. This was not air defense built to be annoying. It was air defense built to seal the one gap that had kept the B-52 alive for decades. And in the opening weeks of Epic Fury, it worked. Think of that phase as 2 different wars fought under the same sky. In Week 1 and Week 2, the airspace said no. On February 28th, when Epic Fury began, F-35s and Tomahawk cruise missiles struck S-300 radar sites and command nodes across Iran. In the first 72 hours, more than 1,700 ground targets were hit. But an integrated air defense system does not die in a single night of strikes. Mobile SAM launchers kept moving. Distributed radar nodes survived. The network was damaged, but not destroyed. The B-52 stayed 500 miles from the border, launched JASSM-ER missiles, and never crossed the line. Not because it was afraid, but because the math of that airspace did not allow anything else. From Week 3 through Week 5, the airspace changed its mind. Sustained suppression and destruction of enemy air defenses by F-35s, B-2s, and B-1Bs eroded more than 80% of Iran's integrated air defense network. The airspace shifted from contested to suppressed, and the B-52 the same old airframe, flying from the same base in England, began doing something different. It flew closer. It changed what it carried. It dropped 2,000-pound bunker buster bombs directly onto an underground ammunition depot in Isfahan. The secondary explosions confirmed that the bombs had reached what was buried inside. The aircraft did not change. The sky did. Once you eliminate the alternatives, the picture becomes clearer. To solve both of these very different physics problems, striking from standoff range while enemy air defenses are still active, and delivering direct penetrating attacks once those defenses collapse, you need two things at the same time. First, enough range to launch from outside the kill zone. Second, a warhead heavy enough to punch through reinforced concrete once that kill zone is gone. The B-2 Spirit has the stealth to go almost anywhere in Week 1. But that is not the problem the B-52 needs to solve. The B-52's problem is volume of fire across two different phases: standoff attack when IADS is alive, and direct attack when it falls. The B-2 handles one of those. The B-52 handles both. The F-35A can carry JASSM missiles internally, but only 2 per sortie, so it runs straight into a volume problem. The Tomahawk has the range for standoff operations, but each missile costs about $2 million. Its warhead weighs only around 700 pounds, less than half the mass of the 2,000-pound BLU-109 penetrator needed to crack reinforced concrete bunkers. In other words, the cost is high and the physics still do not work. It can deliver distributed firepower, but not the necessary penetration. The B-1B Lancer can carry the 5,000-pound GBU-72 penetrator, but that weapon was designed for a different target set, such as missile silos buried under granite. That is deeper than the B-52's problem requires. The B-52 needs heavy strike volume across many targets, not maximum depth against a single one. Using the B-1B here would mean using the wrong tool. The B-52H, the only Stratofortress variant still flying and upgraded with the internal weapons bay modification, can carry 20 JASSM-ER missiles per sortie, 8 on an internal rotary launcher and 12 on underwing pylons. It can also carry GBU-31 bunker busters. Same airframe, different weapons, depending on what the sky allows. The B-52 is the only platform in Epic Fury that solves both equations. Not because it is the most advanced, but because it carries the most and adapts best to changing battlefield conditions. That adaptability showed itself most clearly on the very first night, when the B-52 learned the exact boundary of what the airspace would permit. At 2 a.m. local time on February 28, 2026, at RAF Fairford in Gloucestershire, England, the 8 turbojet engines of the B-52H came to life in sequence. The ground shook with a sound maintenance crews describe as somewhere between a freight train and rolling thunder. The Stratofortresses taxied slowly toward the runway. Heavy, deliberate, turning southeast, they flew for hours and then stopped at a distance of 500 miles from the Iranian border. This is the energy state of a bomber that cannot hide. It traded stealth for payload and speed for range. What it has left is distance, the math between where it stands and where enemy missiles can reach. That math is what keeps it alive. Why exactly 500 miles? Not because it was low on fuel and not because it lacked targets. The reason is that to the east, Iran's S-300 PMU-2 batteries were active, and the B-52 lit up on radar screens like a bonfire in a dark field. Every air defense crew within hundreds of miles could see it. Every battery knew exactly where it was. The geometry of the problem is simple. The S-300 PMU-2 can engage aircraft at about 120 miles. The B-52 was sitting 500 miles away. The nearly 400-mile gap between those two numbers was the portion of airspace Iran's missiles could not reach. And that gap is why the B-52 survived. From that position, the B-52 launched its weapons. The AGM-158B JASSM-ER is a standoff cruise missile with a published range exceeding 500 nautical miles. The math is straightforward. The B-52 fires from 500 miles out, and the missile flies the rest of the distance on its own, pushing another 120 miles deep into Iranian territory before its infrared seeker locks onto a target in the dark. The missile itself is built for low observability, with composite materials, a reduced radar signature, and no active emissions in flight. It does not announce itself. It simply arrives. Each B-52 can carry 20 of them, 8 in the weapons bay and 12 under the wings. 20 missiles, 20 separate GPS coordinates, 20 targets, all from one aircraft in one sortie. The B-52 turns northwest before any of those missiles hit. By the time Isfahan sees the first explosions, that aircraft is already over the Mediterranean. The S-300 operator had a clean track on the B-52 from the moment it rose over the radar horizon. He had perfect tracking data. What he did not have was range. A radar without reach is not a weapon. It is only a witness. Now fast forward 5 weeks. The airspace had changed, and so had what the B-52 was carrying. By week 5 of Operation Epic Fury, reports indicated that an Iranian ammunition depot outside Isfahan had been struck by 2,000-pound bunker buster bombs. The initial blast was followed by a chain of secondary explosions, as the depot's own munitions began detonating in sequence, one blast triggering the next. The fires burned for hours. This was no longer a JASSM-ER strike launched from 500 miles away. This was destruction on an industrial scale. A series of 2,000-pound bombs fell directly from the weapons bay, one after another, straight down onto hardened targets. No standoff, no distance-based evasion, just gravity and mass. The weapon in question was the GBU-31 Variant 3. At its core is the BLU-109 penetrator, a hardened steel casing built specifically not to shatter on impact. Think of the difference between a hammer and a nail. A conventional bomb is a hammer. It slams into the surface and spreads its energy outward. The BLU-109 is a nail. It drives all of its energy straight through the target. Where ordinary bombs crack, flatten, or break against hard surfaces, the BLU-109 is engineered to hold together under the brutal deceleration of punching through reinforced concrete. Dropped from high altitude, the bomb reaches terminal velocity before impact. It weighs 2,000 pounds in total, with 535 pounds of PBXN-109 explosive packed inside the penetrator casing. At that speed, kinetic energy alone is enough to drive the weapon through reinforced concrete, but it does not explode on contact. A programmable delayed fuse, the FMU-143, holds the detonation for a precisely measured fraction of a second after impact, just long enough for the casing to punch through the roof and enter the structure. Then the 535 pounds of explosive detonate, not on the surface, but inside the target. In a loaded ammunition depot, that does not merely destroy the bomb. It ignites everything stored around it. One cook-off triggers the next. The depot does not simply burn. It destroys itself from within. Many people ask why the B-52 could do this in week 5 but not in week 1. The answer is still the same. The aircraft did not change. What changed was what 5 weeks of sustained air defense suppression did to the sky over Isfahan. Once more than 80% of Iran's integrated air defense network had been neutralized, the B-52 could fly at high altitude over Iranian territory without being tracked and engaged with any reliable consistency. That is not invisibility. It is the disappearance of the threat that once made visibility fatal. If you detonate 2,000 pounds of explosive on the surface of a bunker, you make a crater. If you detonate it inside, you make the bunker tear itself apart. The secondary explosions are not collateral damage, they are the point. The strike on Isfahan is clear proof of that. Its significance goes beyond a single ammunition depot. By late March, RAF Fairford, a single runway in the English countryside, was hosting 23 heavy bombers, including 15 B-1Bs and 8 B-52Hs. That is nearly 1/3 of America's entire strategic bomber fleet parked at one airfield. Fairford is the only dedicated forward operating base for U.S. heavy bombers in Europe. Every sortie flown from England instead of South Dakota saves thousands of miles of tanker support and hours of transit time. That means more sorties per day, more weapons on target, and more sustained pressure. Then there is the cost of what comes out of the weapons bay. In Week 1 and Week 2, a single B-52 sortie carrying 20 JASSM-ER missiles put roughly $52 million worth of ordnance into the air. By Week 5, the same aircraft carrying 20 GBU-31 JDAMs put out roughly $600,000 worth. Same airframe, same target list, but 98% cheaper. That shift was not just tactical. It was close to unavoidable. 5 weeks of bombing at that pace drain missile stockpiles much faster than production lines can replace them. Lockheed Martin's JASSM-ER line is not infinite. Once the airspace allows a $30,000 bomb instead of a $2.6 million missile, the pressure from institutions, logistics, and inventory realities pushes the transition, not just tactical reasoning alone. The B-52 did not just adapt to a new sky, it adapted to a shrinking magazine. If you look at the scoreboard, the two phases of Epic Fury tell a very clear story. In the standoff phase, B-52 sorties from RAF Fairford contributed to thousands of strikes out of the more than 13,000 targets hit by Week 5. No other platform can generate 20 precision strikes per sortie at that range without entering contested airspace. The throughput math overwhelmingly favors it. In the direct attack phase, the strike on the Isfahan ammunition depot confirms that the penetrator reached the interior before detonating. Secondary explosions are the signature of a weapon that achieved penetration before blast. They do not happen when the bomb fails. Same aircraft, 5 weeks. 2 fundamentally different physics problems. No new airplane required. Even so, one honest caveat belongs here. An 80% suppressed air defense network is not a 100% dead one. Mobile SAMs survive because they move. Man-portable air defense systems are spread among smaller units rather than fixed to radar sites. The B-52 flying in Week 5 is still not flying alone. It still operates with electronic warfare support and still has fighter escort, lighter than in Week 1, but escort nonetheless. In other words, the airspace had been suppressed enough for the mission, but it was never absolutely safe. What made the B-52 exceptional in Epic Fury is that it solved 2 fundamentally different physics problems in just 5 weeks, using the same airframe, the same base, and the same crews. No other platform in the American inventory shows that level of adaptability at that scale. The B-52 did not change. The war around it did. And once you understand the math behind it, the results stop being surprising. More than 13,000 targets, Week 5. An Iranian ammunition depot engulfed in fire. Secondary explosions caused by its own munitions destroying one another. And behind it all, a 70-year-old aircraft. The same aircraft that had stood 500 miles from Iran in Week 1. Iran built its air defenses to make the B-52 irrelevant. For the first 2 weeks of Epic Fury, that worked. The B-52 had to stay outside the kill zone and throw missiles across the gap. Then the shield weakened. The B-52 moved in. The bunker at Isfahan did not survive the visit. The B-52 is not just the oldest bomber still flying in the sky, it is the most adaptable standoff and direct attack platform ever built, because it solves two fundamentally different physics problems with the same airframe, depending on how much the threat envelope allows. In Operation Epic Fury, the sky changed. The B-52 changed with it. In Week 1, it stood 500 miles from Iran. In Week 5, it was dropping bombs on Isfahan. The airspace wrote two different equations. The B-52 solved both. And the next equation may already be taking shape.